So the final public version of Vite Plus will probably be, it will feel like something like fun.
This is Evan Yu.
Evan Yu.
Evan Yu.
Evan Yu!
I made Vue, I made Vite. Now I run a company called VoidZero.
How is Vite different from Vite Plus?
Your dev experience will be exactly like what Vite is like today. But if you want to go further, it's there for you all the way.
How is the team and yourself using AI?
We started doing crazy experiments like porting Angular compiler to Rust.
What are your thoughts on React Server components?
I've been a skeptic from day one.
Usually when I introduce a podcast, I ask the guests to intro themselves, but I think if someone's watching it and they don't know who you are, I'd be super surprised. I think you're just so well known that everyone should know, or most people should know who you are.
They've at least heard of Vite or Vue, definitely.
Yeah, so I made Vue, I made Vite. Now I run a company called VoidZero, where we work on even more open source projects. There's Rolldown, Vitest, OXC, and yeah, so Vue and Vite are probably more popular, but some of the stuff we're working on in VoidZero are also pretty cool, because Rolldown is a Rust-based bundler. OXC is this full Rust toolchain that includes all the way from the parser to the resolver, transformer, minifier, etc. And on top of OXC, we have OX linked and OX format, which is ESLint compatible linter and a prettier compatible formatter. And there are more stuff we're still working on, but yeah, so we want to mostly talk about the open source for now. Yeah.
Sure. So because you're working on so many things, how do you split your time?
Well, I don't personally write code on all of these projects. Actually, I write much less code nowadays, since I started the company. So at the company, there are many engineers who are way better than me at Rust, and they're now all AI built. So it's like half them and half Claude Code or Codex running a bunch of Rust code. And I am more like I have to decide on what to do on a lot of the DX decisions, decide like what we want to focus on next. And obviously there's also products that like, how do we turn this into a product that will make money, which is something we're still working on. Yeah, so it's it's all the things you need to do to run a company nowadays.
Where do the sort of ideas for the new open source projects come from? Are they largely from sort of internal needs that you realize could help solve other people's problems as well?
So it actually all starts from Vite, right? So when I created Vite, I was just hacky on it. It started as a prototype, and then I was like, we need a bundler. We started with this completely unbundled native ESM dev server, right? And that idea worked great for simple code. But then we started pulling in some big dependencies and realized, okay, this is not going to scale well if you load all the dependencies unbundled. For example, if you have like load-es, which is like 700 files. So we're like, okay, we need something to bundle the dependencies, right? And Rolldown, back then there was Rollup and ESBuild and Webpack. So Webpack does not output ESM, so cannot use that. So I looked at Rollup, and Rollup is quite slow. It's like very slow compared to ESBuild, right? It's faster than Webpack, but it's slow compared to ESBuild. So we used ESBuild to pre-bundle the dependencies, which is blazing fast, and then we serve all the source code as unbundled ESM, and that worked great. And then when it comes to production, we originally was like, okay, let's just use ESBuild to bundle the whole thing for production. And then we realized ESBuild has very limited control over how you split chunks, which is a very common need if you build larger applications, because you want to be able to control, say, I want to put these library dependencies in a vendor chunk so it's better cached. I don't want this chunk to ever change, right? So it has the consistent hash. So even if I change my source code, that chunk hash should stay the same. So users always get that chunk cached when they visit the website. So there are a lot of these kind of optimizations that ESBuild just does not allow at all. Like, it has one default chunk splitting behavior, and that's it. Its plugin system is also less flexible. It's like if there is one plugin that decides that I'm going to process this file. That's it. Like no other plugins can touch it anymore. So whereas we have been using Rollup a lot, we are familiar with Rollup's plugin system. So what we ended up doing is, okay, like say we're going to use Rollup for the production bundling, but ESBuild for the dev pre-bundling. That was kind of like each thing just did what it's best at in this combo. And in fact, even today, Vite 7 is still based on this combination. And that works decently well for a lot of people, right? But obviously there are problems because ESBuild is written in Go, Rollup is written in JavaScript, and which means the production build is actually still quite slow compared to, say, fully Rust-based bundlers like RSPack. And for the dev server, ESBuild, because of ESBuild and Rollup have different plugin systems, right? We cannot apply the same set of plugins to the dependencies during dev, but they are applied to the dependencies during production build. And then there are like subtle interop behavior, like when you have a mixed ESM and CJS graph, ESBuild and Rollup handles it slightly differently. There are like tree shaking behavior differences. So while they both do a good job, right? Like we also patch around all the behavior inconsistencies and all that. We made things work, but deep down we know, okay, it's just two different things that we somehow like cobbled together, right? So in order to A, make the production build faster, and B, make the dev and production builds more consistent, right? The best thing to do is to have one bundler that does both, right? But the problem is, you know, ESBuild is fast, but it's not super extendable. The code base is like, it's all Go. So Evan Wallace, who's the author of ESBuild, obviously he's a math scientist, he's a genius, and he made ESBuild extremely fast, but it's not particularly suitable for other people to sort of extend it or fork it or like sort of maintain a layer on top of it. It's not easy to do that. Right. And also, it's really hard to convince Evan Wallace to do things he doesn't want to do because he doesn't need money and he doesn't care. So we're like, okay, like, and what about Rollup? Can we make Rollup faster? Right. So there are some experiments, but fundamentally, Rollup is written in JavaScript, and JavaScript means it's single-threaded. So we try things like worker polls, put plugins in workers. The maintainer of Rollup tried to putting a Rust parser, SWC parser, into Rollup. That did not improve the performance noticeably, because when you have a mixed Rust and JS system, there's always this data passing cost. Like you're passing big chunks of strings back and forth. If you ever need to clone the memory, it gets even slower. So turns out the raw performance gain from Rust, when you have just the Rust parser, but everything else is in JavaScript, the performance gain is offset by the data passing cost. So it ended up almost having the same performance. Right? So we're like, okay, drastically making Rollup faster is not really technically possible. So the only option is to rewrite a bundler that just like is completely designed for Vite, essentially. And it needs to be blazing fast, right? So that starts all the quest of like thinking, okay, what should we do? So we decided to originally the idea is to fork Rollup in Rust. Not fork, port, right? We want to port Rollup to Rust. That's why the project is called Rolldown. So it's Rollup, Rolldown. And started out as a direct port, but we still realized code written in JavaScript isn't super easy to port directly over to Rust, because JavaScript is very dynamic. It's a dynamic language, right? Even if you use TypeScript, you can still just like mutate things as much as you want. And Rust is very strict about memory. It's strict about life cycles, ownerships, etc. So you just have to structure things very differently compared to JavaScript. So it'll never be straightforward to just port existing JavaScript code to a language like Rust. It's pretty much a rewrite. And we ended up actually, we also wanted to have the best of both worlds, right? Mm-hmm. Rollup itself is a pretty lean core. So if you want to turn Rollup into a production ready preset, it's actually pretty involved because you need something like the node resolver plugin. Like resolving node modules is not a built-in feature. It needs to be added via a plugin. You need to add CommonJS plugin to support CommonJS modules because Rollup core is ESM only. And then you have to add just a bunch of plugins, like define, inject, replace. A lot of these features are built in ESBuild, but they require plugins in Rollup. And what's worse is most of these plugins in JavaScript land, we implement it as a extra full AST parse transform codegen. Like, so every plugin actually does the full, like, take the code from the previous plugin, parse it again, transform it, generate new code, generate new source map, and then you have to merge all the source maps together. That's why JavaScript build system gets slower and slower, because every plugin is just like repeating this over and over. So we're like, okay, we need to have these built in as well. So we ended up having the scope of ESBuild, but the API shape of Rollup, and that is Rolldown, right? But in order to build Rolldown, we're like, we need a parser, we need all the transforms, right?
Yep.
We need a minifier, we need a resolver. So how do we get that? And that is where OXC comes in. OXC is the set of low-level language toolchain that gives you all of that. So the author of OXC was working at ByteDance back then, and I had an eye on the project for a long time. So Boshen, he's the author of OXC, and he's now our VP engineering at VoidZero. He didn't join the company immediately when I founded it. I was trying to get him to join, but he just like, I don't know, like, but we started building Rolldown on top of OXC anyway. We're like, well, this is good stuff. Like, I believe this is because I looked at all the available options, right? I want something that's composable. I want something that has each part of the tool chain that is individually usable as crates. I want it to be also extremely fast, right? So we look at OXC versus SWC. OXC, the parser is like 3 times faster than SWC parser when they're both written in Rust, because there are a lot of these design decisions and low-level technical details that just led to this performance difference. The main thing is Boshen has, been obsessing about parser performance and linting performance for most of the part before he joined the company. And like, for example, OXC uses something called an arena allocator, which put all the memory allocation for the AST in a consecutive chunk of memory. It just like allocates a big chunk of memory and put the AST in it directly. So you have faster time of dropping the memory. It also unlocks some interesting things we did that enables fast JS plugins in OXLint, because the consecutive memory allows us to pass the whole chunk of memory to JavaScript without cloning it, and then deserialize it on the JS side. So there are a lot of benefits, but back then I was looking at the project, I was really impressed, and we decided to build Rolldown on top of it, and eventually convinced Boshen to join. And so now the scope of the company essentially becomes like, we have this vertical Rust stack that starts all the way from the parser. It covers all the way up to bundling, to Vite, and then we have linter, formatter, test runner, right? So we have a whole toolchain. And what we're doing next, actually we've been working on it for a while, is to put all these things together into a coherent package so that you don't have to install 5 separate things just to get the base app working, right? You also don't need to have like 6, 7 different configuration files. We just like put them all in one config file, and they're guaranteed to work together because they're all based on the same parser, the same transform pipeline, so the same resolver. So there will be no surprises. For example, if you use Webpack ingest, right, you have to configure their resolution logic separately because they just don't use the same thing. So so the vision really is like, okay, let's just like build a vertical stack that just works consistently across the place. Make the dev story, the dev experience as straightforward and fast as possible, right? Performance is like a big thing. I kind of took it as a given, but you've probably seen tweets about how like Rolldown is like 20 times faster than Rollup. OXLint is like 50 to 100 times faster than ESLint. OX format is like 30 to 40 times faster than Prettier. So our goal is to really like make it compatible so you can migrate over without doing major refactors, but you just get these huge performance boosts. And now your test loop, your linked check, and everything will just be much faster, smoother, and so that would allow people to build more apps faster.
I love how quickly that sort of escalates from, we need this sort of build tool for Vue to, I want to improve that piece now, so I want to improve that bit now. And yeah, as you said, you do really own sort of the full vertical stack. That's very impressive, and it is very quick. I was telling the guys before it started, at one of my old jobs, we started on a legacy project, and it used Webpack, and it took like 50 minutes to build. I have no idea what was going on, but like the first thing I said to them was like, we need to switch this to Vite immediately. Because like changing CSS, you'd have to wait like 2 minutes for a rebuild and everything. And I was like, this is not good. Like, we need to use hot module reloading. Like, when I save the file, it should make the change. So yeah, Vite really definitely helped with that. And I think the progress and sort of the rate Vite has taken off is super impressive. It's on like 200 million npm downloads I saw monthly or something crazy. It's
we crossed 50 million weekly just a while ago.
Yeah, that's mind blowing.
I was thinking of the 50 million. There's probably a bit of inflation from these like vibe coded apps. That's all just like scaffolding throwaway Vite apps. But
yeah,
still, like it shows a lot of people are probably a lot of AI agents are using it.
I was going to say the engineering team at Better Stack are huge fans of Vue. So it's a Rails app on the back end with Vue on the front end. And they've got some questions which I'll ask throughout the podcast based on where it goes. But you mentioned something about bundling. And one of their questions was, because they use import maps in Rails, where do you see the future of bundling? Because you don't have to bundle much if you're using import maps. So yeah, where do you see it going?
So I actually have this dedicated page on Rolldown's documentation where the title of the thing is called Why Do We Still Need Bundlers?
Have you been asked this a lot by any chance?
Yeah, I mean, like DSH is very vocal about no bundle, no build.
Yeah.
So kind of have to pay attention to that. And so import maps work to a certain extent, but, unbundled in general, like, is a concept that works only to a certain scale. Like, if your app's like below 1,000 modules, right, your whole module graph probably loads within couple hundred milliseconds, and that's totally acceptable. And if you know you're working within that constraint, that is great. Actually, it's lazy. It's lazy by default, which means if you have a big app and like each of the page is kind of siloed, have its own sub-module graph, it works decently well. That's why Vite works decently well in development, right? But it's not a silver bullet, because what we noticed with Vite itself, and the reason we're working on something called full bundle mode in Rolldown, is unbundled mode has its limitations, which is like the bottleneck is really the number of modules, right? So there are many apps where they are loading thousands and thousands of modules during development, right? You could be loading like 3,000 modules, and that would choke your browser. The bottleneck is at the network level, because with native ESM, you're sending an HTTP request for every module to fetch it. And if you have a deep import graph, it actually has to fetch the first module back and realize, okay, I need these additional modules, and I fetch those. And then I fetch those, like you have to traverse the whole graph eagerly before you can actually evaluate the first importing module, right? So if you're on a bad network, you have chances of like multiple network round trips before you can actually render the first thing. And then if you have thousands of modules, the situation just gets amplified by that network. Like even in local development, in a Vite dev server, if you have like more than 3,000 modules, it'll take like 1 or 2 seconds to load it locally. So imagine what that would do in production over the network, right? You really don't want that. Because if you bundle it, it'll probably take like 100 milliseconds, right? So it's like free optimization on the table that you should always take when you cross a certain threshold. I think the main argument of avoiding bundling and build tools altogether is just people got tired of configuring the tools, right? They probably ran into bugs, they ran into configuration issues they couldn't figure out, and because Webpack made it so complicated, everyone just kind of, when you think about configuring the bundler, it's not a job for me. Like I don't want to do it, right? So I think like people just have this resentment about like when they hear the build step, they're just like, it's bad. I want to avoid it, right? So in a way, what we want to do with Vite and the set of tools we're doing is like we want to make these concepts so straightforward, and it's never going to be straightforward for big complex apps, right? But we want to make it simple enough for a fresh app so that you don't need to really think about it too much if your app is, not super complicated, right? So you should be able to just say, okay, spin up this app, it's using Vite, and I know things will be great. So in fact, I know people, there's a community jam called Ruby Vite Rails or something, that just makes Vite work pretty well in Rails. I think the no build setup has its benefits, right? It makes you feel comfortable because like you can avoid a lot of dependencies and like uncertainties that may make things break. I think there's also some people's like, their loss of trust in the build system is like there's always going to be something that goes wrong. The build will break when I upgrade the dependency. They can't indeed avoid all of that, which is tempting. But I think at the end of the day, if the tech is good enough and stable enough, right, you always want the best possible UX for your end users. And doing full unbundled means you have to stay within a very limited constraint of size of your application. And you have to worry about optimization too, because you have to think about like, am I not accidentally importing too much on a certain page I'm visiting, right? How do I cache my modules smartly? I believe even with unbundled, Rails still need to do something kind of like a pre-process step to stamp the modules so they're cached properly. So inevitably, you still need to pay attention to optimization in order to make things work. I would say it definitely works for a very decent number of use cases, but it's not going to cover all use cases. And some people just build really large apps, right? That has a lot of features. So you can't just force them to go unbundled and then lock them into this like unoptimizable performance situation.
So for those who aren't familiar with it or too much, how is Vite different from Vite Plus? And then what do kind of people get out of that?
So Vite Plus, we are going through a little bit of like a mini pivot in what Vite Plus really should be at the moment. The idea here is if you're just getting into JavaScript development completely fresh, like you're new to JavaScript development, you have a fresh machine that never installed anything. Like how do you go from like zero to a working app with hot module placement, all the best practices, linting, formatting, testing, all figured out for you, right? Right now, that's a lot to learn. Like the first thing you need to learn is like, what is Node.js? How do I install it? What is a node version manager? Which patch manager should I use? Which build tool should I use? Which linter should I use? You have to answer all of these questions. We want to remove all of that questions. Like we give you this opinionated starting point, and it's like, you don't even need to install Node.js, right? So we're experimenting with this new way of working with Vite Plus. Is like curl, like HTTPS, vplus.dev install, pipe bash, and then vp dev, vp new, and you have a new project, and then you vp dev, and you have a full suite of things going, set up for you. And you have the linter, you have the formatter, test runner, bundler, everything. You can also use it to scaffold a motor repo. It has library bundling. We do plan to add built-in like things like link stage, managing your change log if you're doing a big motor repo of libraries. And then there is also something called VP Run that is a runner similar to like PnPm run, but like you can, it's a bit more sophisticated, kind of like NX, where it can figure out the right like order to run your tasks and also cache them smartly. This is opt-in though. So it's like this whole set of thing that, you know, if you don't need these additional stuff, like you can still treat it just like base Vite, right? Your dev experience will be exactly like what Vite is like today. But if you want to go further, go all the way scale into a enterprise level production ready monorepo, it's there for you all the way. And also like because it's built on a lot of these proven technologies that's being used by people in those situations already. Right? So that is what we hope to bring, right? So we are converting a lot of existing users to our open source offerings, like where people are migrating from Webpack to Vite, they're migrating from ESLint to OXLint. What we hope Vite Plus serves is the this sort of like, what do I do if I'm just getting into JavaScript? What's the fastest and simplest way to get started? Right? We want to answer that question, and also to make it work really, really well with AI.
Is the goal of the company then? I think a lot of people get scared when they hear there's a company behind open source projects because you might start sort of paywalling certain features. But is it more the goal is you could always do what Vite Plus can do yourself. It's just a lot of configuration, and Vite Plus is sort of just a convenience and packages it all as one, as you said. So you would never paywall a feature.
Yeah. So we sort of teased the idea behind Vite Plus's licensing, right? We said, okay, like if your company is above a certain threshold, you need to pay for it. That thinking has been evolving because like it's where we've been talking to a lot of interested companies and just trying to see like what would be the good balance of getting it into the hands of more people and create value versus like allowing us to capture value and be sustainable, right? I think we're probably going to move that threshold like way up. So it's only a very small category of companies would have to pay for it. Right? So the majority of users should be able to just enjoy it for free. And also because we are working on some ideas that's more service-like rather than just pay-getting features, right? So a service that pairs with Vite Plus that sort of improves the code quality and monitors your code quality and gives you ideas or tips, like helps you improve certain things, like because there are a lot of like domain knowledge that we can now make scalable through AI agents. So that's the direction we're kind of exploring.
Okay, I was going to wonder as well, in sort of Vite Plus making everything convenient, do you think that AI can do that with existing solutions, or have you had sort of experience with just asking AI to piece together the format of the linter, the build and everything, or do you think it's going to rely on old tech because of its training data and create a bit of a mess?
So we see a lot of AI scaffolded apps still using like Vite 6, for example, right? Because like one big thing is when we release a new version, when we ship new features, it takes time for the models to train on those data, right? Models is always going to lag behind the latest news and tech. So that's part of the things we want to do is like, for example, if we release a new version of Vite Plus, it's going to give you, so first of all, it will come with its own agents.md and skills. So when you upgrade Vite Plus, it just upgrades, it'll patch the part relevant to it in your agents.md, and and link to the skills that's being updated in your npm package. And then there's also, we could give you a prompt that just, tell you like, if you want to upgrade from this version to this version, like this prompt should help your agent do it more smoothly. Right? So a lot of that will have to come from the tooling authors, right? Because you can't. One thing we've noticed is we got OXLint and OX format and VTest. They are used in OpenClaw, right? And OpenClaw is a crazy code base. It's like 54,000 lines of JavaScript and moving at crazy pace. And the author is just merging stuff that without reading it. And it's like, there is a lot of things that just doesn't make sense in there. So we're looking at like some PRs that upgrades like OX Lane or like upgrading, like adopting OX Lane. It just like hallucinated options that isn't there. And we're like, wait, like we don't have this option. We have to. And then like when it's doing type checking, it just like fix the type checking. Okay, I'm turning this rule off, so the type will pass. So it's like AI will take shortcuts if you don't give it guardrails, right? And the more important thing is Peter, who's the author of OpenClaw, he is not a TypeScript developer. He just chose TypeScript to do it with. So he's not a like tooling expert. He's not experienced in this field, right? AI helped him do it, but you know what we as the authors of the tools that's being used by AI, we notice like where it falls short, and it's like, okay, like if you keep doing this without us actually pointing that out, your code is gonna fall apart in 3 months, you know. So yeah, so this is kind of the value we think we can provide in the AI era is like how do you make sure like you are shipping fast without breaking things? How can you like keep shipping fast features with AI? Because like the velocity of code like shipping is just increasing massively because of AI agents, right? People can ship features much faster than they can, but are these features all properly reviewed? Are they all, you know, when you merge 20 PRs a day, is the code base still, you know, properly maintained as it should be? Like the code health kind of like, you know, it's very volatile. So you kind of have to go from time to time to do like we do with human development, right? You ship features for a while, you have to just stop and think like, okay, we need to clean things up. We need to pay off the tech debt that accumulated. So with AI agents, we're shipping much faster now. We're also accumulating tech debt much faster, right? So you need to leverage AI to pay down that debt as well. So yeah, I think this is the part people are overlooking and in need of solution right now.
Yeah, no, I had a look around the OpenClaw code base, as you said, and it is a bit chaotic. It definitely is a great example of what happens when you just let AI unleashed and let it do whatever it wants without any sort of oversight. It's been a fun sort of few weeks on the internet of that trending and seeing everything it's been doing. But yeah, I was also going to ask in sort of the role of AI. I think do you change the way you build a formatter and sort of a linter so that AI agents can use them better? Has that sort of shaped the future, or do you think the way that you've just built formatters and linters to be fast sort of just helped in the age of AI? I think obviously them being fast, AI agents can use them.
That's definitely a good thinking, because like we are starting to think about that problem, because like the original scope of these linters and formatters is actually massive, because we're trying to be compatible with something like ESLint and Prettier, which has been like in production for years, for a decade, where people have all these custom rules, like legacy use cases, and we're trying to be 100% compatible with it. It's like it's a massive amount of work that we finally achieved, because like we just recently hit 100% ESLint plugin compatibility. We passed all ESLint's plugin tests, and we also reached 100% conformance with Prettier and our formatter. Right.
Yeah.
So these two milestones means like, okay, like we can now confidently recommend people to move over to our tools. And also, what's next, right? Where, you know, that's the good question to ask. Like, how does linting and formatting, you know, how should they adapt when agents are using it? Right? It is definitely a question we are working on actively here. Yeah.
Basically, pending an answer on that one, I'd say. It's still evolving. Yeah, it's AI is certainly changing a lot of things in the coding world, so it's interesting to see.
Sticking on the topic of Vite Plus, so you showed it off at ViteConf 2025, and you showed a feature that was Vite install. So my question is that feature still a thing? And how much overlap is Vite Plus going to have with something like Bun?
That's a good question, right? So things did change a bit since ViteConf. Right. I would say the final public version of Vite Plus will probably be. It will feel like something like Bun in a sense, right? So the onboarding experience, like I said, if you have a fresh machine, you're like, I want to start building a web app as fast as I can. You you just curl the script, and you get a global binary called a VP, and you do. So when you are inside a project, right? If you have a .node version file and you have a package manager field in a package.json, which is the common things we use to specify these things, the environment, the JS environment you're working in, right? V plus. So when you say VP run build, it'll automatically use, even like when you just say VP build or VP lint or whatever, anything that involves running JavaScript, it will just automatically pick the right version of Node and the right package managers and do that thing for you. So so in a V plus enable, actually, even if you're not using V plus in that project, as long as you're using these conventional environment sources, right, you can use V plus as a replacement for NVM. You can use it as a replacement for core pack. You just stop thinking about like versions. The idea is like, because when you run your workflow, you do it through, you also stop doing npm run. You use VP run. So the idea here is like when you do VP run, all the, it'll use the right node version, it'll use the right package manager version. So, and do the right things. So, Vite install means, it'll just, so we don't have a package manager of our own first, right? So it's more like a core pack equivalent where, I don't know if you've used the package called NI. It's from Anthony Fu.
Yeah,
He's that one.
So NI essentially means like when you run NI, it'll automatically infer the right package manager to use, whether you're doing run or install or uninstall, whatever, right? So Vite install is essentially that plus the package the package manager part. That's what core pack does, right? So even if you don't have anything else installed, you go into a project and the package manager package.json file has like package manager pnpm at certain version. You run Vite install. It'll automatically check if that version of pnpm is installed. If it doesn't, it'll just install it and run the install process with pnpm install. So yeah, so the idea is we want to be, solving more than just linting and formatting. It's like the whole, like all the common things you'd need in your JavaScript workflow, right? We want to eliminate these common problems where like, so a beginner don't even need to think about it, right? So if the first time you scaffold a project, we will use the latest LTS of Node and we recommend PNPM, and it will also write those information into your project. So the next time you come into this project, it's always using the right combination of things. Right?
Why do you recommend PNPM out of curiosity?
It just has the right balance of feature set and correctness and disk efficiency and speed and good workspace support. Like things like catalog, it just, when we compared all the workspace features, we just find PNPM still to provide the best balance of it. And it's like, we know Bun is like ridiculously fast, but PNPM has been fast enough for a lot of us. And also like, we don't really rule out the possibility for us to support Bun in our runtime and package manager version managing, right? So you can say, I want to use Bun and we'll just run things with Bun.
So with Vite 8, I think you said it was supposed to release after Lunar New Year, right?
Yes.
Yeah. So what are a few things in the beta that you're focusing on before you actually drop it?
It's really all stability. So ecosystem CI, like we have a really massive ecosystem CI system where we run Vite in downstream project that depends on it. Right. So one recent things we did is we, spell kit, all the tests now pass on Vite 8. So, that's big for us because and stability is really the most important thing. Because if you think about it, we are swapping out 2 bundlers with a new one we built from scratch. So it's like we are swapping the engines of a flying plane and hope it will just operate smoothly afterwards. She just never hurts to be more careful about it.
I was going to ask earlier, actually, the choice of Rust, was that sort of just people on your team had knowledge of Rust? Because I see a lot of people in the TypeScript world prefer Go because I think it's a closer sort of port over, and that's why TypeScript is even going to Go for that compiler.
Yeah. So I think the choice of like TypeScript team being ported to Go is, like I said, Go is a much easier language to port TypeScript to, right? Because the mental model is much more similar. I think one of the big reasons that's kind of a blocker for us is Go has kind of subpar WebAssembly support. It produces huge WebAssembly binaries, and its WebAssembly performance is not that great compared to Rust. And then with Rust, the thing is, yes, a lot has to do with available talent, people who already are passionate and invested into the ecosystem. For example, when we looked around on the foundations to build on, there isn't a set of parser, or the toolchain that is as well implemented and as composable. And basically, like OXC is built to be built on top of, right? It's these low-level utilities. We don't see that kind of equivalent in the Go world. ESBuild has its own parser and everything, but it's not. It's a big monolithic system. You can't just take its parser out and somehow use it, right? But also, like all the features in ESBuild, like define, inject, transforms, minification. In order to get the best performance, it's implemented in 3 AST passes, which means like in the same AST pass, you may have mixed concerns of we're doing some transformation here, we're doing some inject feature here, we're doing some minification feature here. That makes it not ideal for an extensible system where, like, for example, we want to be able to ship more transforms and allow people to toggle the transforms on and off. Right? We want to allow people to write their own transforms. You want to have a linter system where we want it to be cleanly layered, so we can also have more people work on it at the same time. So it just has a lot to do with what we have available. Rust is also really performant. It is indeed a bit tricky to write good transforms with Rust. We had to spend quite a bit of time figuring out the good architecture for the visitors and transformer pipeline, because the memory ownership issue, like when you traverse really down in a tree and you need to change the parent tree, it gets really tricky, right? But we figured something out. It's much easier in Go, but when we think about it, we do want our things to be able to compile to WebAssembly and run in the browser, right? So like Rolldown is able to run in the browser and run very decently fast. I mean, ESBuild is able to run in the browser, but Rust's WebAssembly is just better.
The sort of other question I was going to ask based on the team building in Rust and stuff, how is the team and yourself using AI? You mentioned earlier that a lot of people are using sort of AI on the team. Do you find that AI is good at the work you're doing? Because I feel like sort of web dev and building a website, there's so many examples on GitHub of that. So AI is trained quite well. But I feel like what you're doing is sort of a lower level of technical, or a higher level of technicality at least. So is AI helpful there, or are you still doing a lot of manual coding?
It is definitely helpful. I think the thing is the field is changing so fast. I think just last year this time, I was a skeptic. I'm like, well, I tried it. It just doesn't work for me because the work I'm doing is too low level, right? And then I guess, so Borshen, who is the lead of OXC, he's probably the deeply AI-pilled person in the company right now. So he started going crazy with the experiments, and like, I think last month there was like a week he shipped like 60 PRs with AI and like just running agents in parallel. And then we started doing crazy experiments like porting Angular compiler to Rust, and we just like threw at it and see if it's gonna work. And somehow it's working, like, so maybe we'll have something along that lane in the future. But yeah, so I think like we are constantly being like updated, like our perception of like the reach of capability of AI is just being refreshed every few months with new models coming out, with better harnesses being implemented, and better, these new practices like use plan mode and then say, write your agents MD. This is like use these tips and tricks. So when you apply these little things, you realize, okay, like it is indeed getting better and better. And so usage still varies by people, right? We encourage everyone at the company to use it to the extent where they see fit, right? We give them a monthly credit so they can use Clockwork Max if they want. So I think some are really happy about it and actually pretty vocal about it. And obviously they are landing really good PRs, right? I think it really depends on how well you can use it, right? It's part of it. It's just the raw model capability. Part of it is like the harness you're using, but I think the harness layer is kind of like JavaScript frameworks back in the days. It's like everyone is just like doing their version of it, and they're doing more or less the same thing. Maybe this thing has a few different tricks up its sleeves, but a few months later, everyone is doing it, right? So it's just gonna be sort of like this very competitive field, and model is the same. Like every few months, like you see Sonnet 5 is about to drop. I think DeepSeek is about to drop a new model. It's like, it's just gonna get better and better. And I think it's pretty clear that AI is extremely capable with the right steering. But I think the steering part is still extremely important. Right? You can't expect someone who has zero knowledge of Rust to be able to work in the OXC code base, even with AI. He probably wouldn't even know how to prompt, right? But someone who has been already efficient in OXC as a Rust engineer himself with AI becomes much more productive and can ship more features faster. Right? So I think that is that's like my general take on it. So I would say I'm probably like the one who, the amount of code I produce with AI is very, very little, very minimal compared to other engineers in the company. I use it more for research and just like a sounding board.
It's certainly a weird world the sort of coding's going in, and I'm finding it sort of hard to stay on top of learning how many sub agents you're supposed to use, parallel agents, what markdown file you're supposed to have in your repo now. It's changing all the time, so it's curious to see where we sort of land on that in the future.
If we were to go back to Vite just for a bit, so in Vite 7 you released React Server Component support, and in my opinion, React Server Components hasn't been the slam dunk that the team thought it would be. I mean, there are some meta frameworks that are not accepting it, like TanStack, and I think Remix have even gone their own complete direction. So, what are your thoughts on React Server Components, and why do you think it hasn't landed as well as it should have?
Yeah, I have always been really conservative about it, or I've been a skeptic from day one. That's why we never considered implementing something similar in Vue. I think the fundamental idea here is what exact problem is it trying to solve? And I think it was when it was being pushed, right? I think in trying to hype people up, it's being sort of advertised as the silver bullet that's going to be the best thing ever. It's going to make all your websites faster. Turns out when it lands, people realize, okay, like maybe I shouldn't use it in all cases. It only applies to a certain type of cases where it'll benefit you. And then in other cases, it's just a bunch of trade-offs, right? Because like the parts that lives on the server, all the interactions actually have to go to a network round trip. And that's actually pretty bad for like offline first experience, in my opinion. And then you can't really fully escape the hydration cost, in my opinion. And you are offsetting a lot of the client-side hydration cost. You're offloading that to the server, right? Now you're bearing the cost of every request. You're doing more work on the server. So people have, these people have these like conspiracy theory where like the cell is pushing it to sell more compute. I don't really think that is what it is, right? But it is also true that using RSC means you have more server load. You're running more things on the server. You're using more compute minutes. And ultimately, there are other benefits, like, say, if you put a part of your thing on the server, you save the bundle size. There are a lot of different ways to solve that problem, which doesn't necessarily involve you having to run Node.js server, right? And a lot of this is my personal opinion, right? Like, in front end, we tend to say, okay, like, architecture really matters. Do you want to use an SPA? Do you need server-side rendering, right? RSC is even more specific. Like, do you need RSC is a very important question and a very hard question to answer. And when you say yes, you also need to be aware of the cost you're paying, because I think one of the reasons it didn't get really well adopted is, first of all, it's extremely complicated. The thing itself is hard to explain. How it works is hard to explain. We had to like go really deep because it actually requires build tool level orchestration to make the whole system work, right? And then, so very few people actually understand how raw RSC works. Most people know about it through the implementation in Next.js, because raw RSC is something that an average user wouldn't be able to set up by themselves, right? You'd have to really understand how to all fit together to be able to put something up from scratch with plain React and Vite or Webpack, right? It's not for the day-to-day development, right? So you want to use a framework. That is what's built for. But in order to use RSC in a framework, the framework has to make design decisions to sort of how do you present RSC in a way that would give you the decent DX. And I think Next.js didn't nail it, I would say, right? Like the use server, use client confusion, the mixed graph where like when you make something use server and something, these things just stop working. Like you're limited to only be using these things, and then you have to import a dependency, and the dependency is like, it doesn't work on use server. Now you have to use client again, right? So this kind of back and forth, I think it's just like a lot of these little paper cuts in DX makes people think, okay, like in order to get the, claimed benefits, now I have to also just put up with this annoyance of DX all the time, forever into the future. Is it really worth it, right? So I think it's fair that people are like, do I really want to use it? And also like even for framework authors, right? Vercel had this really close relationship with the React team, so they can collaborate and iterate on it fast. But for third party, I wouldn't even say third party because technically Vercel is third party, right? But for other frameworks like Remix and TenStack, it's not that straightforward for them to work on this problem, because a lot of these API iterations from the React team is like prioritizing Next.js. So I think I'm not really criticizing them for it, because like it's like, okay, Vercel is their design partner. They want to partner with Vercel to get this feature polished and ship it, which makes sense, right? But I think, and because of that, like Next.js essentially was the only real way for people to use RSC. And that experience hasn't been super great. So I think that's why it just didn't pan out as it could. And also, like, I think the general premise of, even in an ideal world where RSC has like perfect DX, I still don't think it's going to be a silver bullet in all cases, right? So you need to be fully educated on where it makes sense, where not. So just too many trade-offs.
I assume there's been no sort of push to implement something similar in Vue, because obviously linking this back to Vercel, they bought Nuxt Labs, which is the sort of meta framework on top of Vue for piecing it all together. How's that sort of relationship been between Nuxt and Vue now that Vercel own them?
Honestly, it didn't change much. I think Vercel has been pretty hands-off since the acquisition, so the Nuxt team is just happy to be able to keep doing what they do. There are probably some efforts to, say, make Nuxt work better on Vercel, make a first-class citizen. But I think the thing is, Vercel is aware that some of the images it has in the community, and they would be really careful not to damage it further. And so after acquiring Nuxt, right, the last thing they'd want to do is to force Nuxt to do things people don't like.
Unfortunately, Evan had to leave early to take an important call, but we really appreciate his time and all his insightful opinions on all the questions we asked. If you have any future guests you'd love on the podcast, please let us know in the comments. And if you have any feedback in general, also let us know too. We'd love to hear it. Find us on anywhere you listen to podcasts like Spotify or Apple Podcasts. And until next time, it's a bye from me.
Bye from me.
Bye from me.
It's a pleasure. Thank you all.
Thank you very much for joining us.